So dropping. So what is dropping? If you want to remove any column, we can use any column or anything, or we can use a drop. Here we are using here we have series object. We have values 0 to 4. It has some index. So we are trying to drop yellow. Yellow is the index label. We are passing index label with this bracket. If it is any index, we have to use square bracket, index 0, 1, 2, 3. But here we are using label. That's why single label. That's why we are using this one, this bracket. Okay. If you want to drop more than one, so you have to pass it with the comma separator in list form. Okay. We are dropping blue and white, blue and white. So that's why passing it in the comma separator. Only thing is, main thing is you can use that series or data frame as a drop functions. You can use that function. You can drop whatever you want to remove. Here the data frame we are removing blue and yellow. Okay, blue and yellow. See here in data frame we have a row and column, but default if you set it anything blue, it find the row label and remove it. Okay. Suppose if you want to remove anything on the column side, okay, uh, in data frame always remember this one is zeroth axis, axis 0. Default it come if you assign anything, a drop anything, right? Here we are using a blue and yellow. It finds a row because default is axis 0. Axis 0 in the sense row. Axis 1 is column. Okay, axis 1 is column. If you want to remove any column, okay, you have to use second parameter. You have to specify axis is equal to 1. Axis 1 means it considers the column. Okay, axis 1. So it will find a pen and pencil. Pencil will be removed. Some arithmetic and data alignment. Okay, we will see now. Here we have a series 1 and series 2, two objects. So white, yellow, uh, and what is the common blue. Blue are common. If you add two series, okay, so whatever the common items, right, the kind of common uh, label that is getting added, index label. Okay, so rest of the labels as none. Okay, here white as a value and yellow has value is getting added two values, and the blue all values, remaining value remain label, index label as none. So we can do the concatenation between two series or two frame data frame also the same thing having the. Here we have a two data frame, red, blue, yellow, white, ball, pencil. Here mug. Okay, so we are adding these two data frame. The count of whatever common, right? The common items is getting added. The remaining items having none. Okay, so it works like this. Here this column is new. Okay, it doesn't have both data frame don't have this rows. That's why entire row is like paper and the mug also entire column is not because a new. Okay, we can use this method also. We can use a frame one, data frame one plus data frame two, or frame one, data frame one dot add. We can use add functionality. Both are similar. Both are working in the same way. So operation between data frame and series. So we have a data frame object, first one, and a series object. Here, this one is a data frame, DF. This one is a series. So we can do operation, addition, subtraction, we can do. Okay, it works. Only thing is the values are getting added and subtracted. So if you want to change any values, so you can change. Here, so mug. So in series object, only mug is getting added some count. Okay, but in data frame doesn't have the mug column, so it returns none. Whatever commons, it do the operation for a common item. Rest of the item gives not a number. Okay, we can do the function by element. Okay, so we have a data frame object. The entire data frame object, it has some items 0 to 16, 0 to 16 in matrix 4 cross 4. Okay, 4 cross 0, 1, 2, 3, 4, like this. 4 cross 4 matrix is there. So we are applying square root. Like this, we can apply. NumPy has various square root, log, whatever we want, we can apply. Okay, here all elements, the functions, so applied on element wise. So if you want to use, suppose if we want to apply any user defined function, okay, so we can we have a function, okay, f, okay, and this one is a lambda function, this one is a user defined function. Okay, any so if you are familiar with the lambda, you can write a lambda function, or you can write your own function. Okay, like this normal function. After that, we have a iframe object. Iframe object, apply f. So the function is getting called for each item. How it is getting called? What is the functionality here? We are getting max value minus min value. Max minus min. Okay. Here, what is a max minus min? Max is at 12. 12 minus 0. All rows, all columns. 12 minus 0 except mug. 12 minus 0 is 12. Okay. So after applying the user defined function, it returns max value minus min. That's why it's returning all columns with 12. Okay, it returns like a series because it's applying is computing a max minus. So if you want to apply the row wise is getting applied. If you want to apply, we have to specify the axis one. So the same thing, user defined getting function is here. Our objective is we can apply some function, user defined function on every element, and the data frame dot sum. So it's a statistics item, sum, mean, and the standard deviation. We can get it. There is a one common method, frame dot describe. For that items, for that content, it returns count, how many counts are there, mean, standard deviation, minimum value, 25th percentile, 50th percentile, and 75th and maximum. Okay, describe means it describe all the entire data set. It describe entire data set. This is a very important thing. So whenever we are handling data, first thing is we are calling this function. We can see the statistics point. Okay, what is the mean, standard deviation, 20 plus, everything. Okay, through this describe function.